Thanks for attending the session. Unfortunately, I forgot to record this session, which won't be available in later. Maybe I can uh, record it myself. Thanks for attending. You can leave the session. Yeah, good afternoon all. Sorry, the live session was not recorded before. I am just going back and giving an overview. The exams will have multiple choice questions and multiple selection questions, which will compose of less than 50 questions, and you will be given a time period of 3 hours, and these questions will be similar to your assignments that you have previously gone through. And other than that, um, this today's session we covered again an overview of the whole subject from starting till the end, which is you can always refer back the previous 4 doubt clearing sessions that have been conducted. And apart from it, there were some doubts related to uh, the exam in terms of what is the time duration, and which is standard 3 hours, and this exam will happen in online mode, as you know, and also it will cover all the concepts of solar geometry, comfort, thermal adaptation, heat transfer, properties of opaque materials, and also glazing, shading devices, sound and sound defects, how to find these reverberation time, and other concepts related to sound, and also lighting. Finally, lighting we also, which will cover about in terms of mostly daylighting concepts, the concept of luminance, luminous intensity, luminous flux, all these will be covered. And all the best for the exams. Maybe I'll also share the combined presentation. I'll just maybe give again a run through of the presentation, especially for the people who are not able to attend this revision session. This revision session, we just look back into the whole subject. Major concepts that we have looked into is the solar geometry, the heat transfer properties, how to calculate, uh, look into how to solve these various problems, use the formulas that are discussed, and then try to practice few uh, formula related solutions. Example, this SSGC, uh, always look into these units. You would have come across many unit related questions also. Units also gives an understanding of the whole concept also, because based on the units also you will be able to reduce what and all the parameters that are involved. Example, thermal transmittance unit is watt per meter square Kelvin, which is what is the amount of heat that is being transmitted divided by meter square Kelvin. Meter square is the cross section area that is being involved in that property also, and also the temperature. So it's like all these parameters are involved in a particular concept. And moving further, the solar geometry, as you know, the main concept is the latitude. Try to remember whether the latitude is like beyond the equator or below, above or below the equator, which decides when the winter or summer solstice is for the particular place. And sun path diagram we covered. Sun path diagram we looked into the concept of altitude and azimuth angle, which are used in to do stereographic projection. And he also talked about this concept of solar time, where how to can use this solar time formula to calculate the exact time, how ahead or behind we are on the actual time IST. And when we talk about solar radiation, we talk about we look into irradiance radiation, solar temperature. Solar temperature is an indicator of indoor temperature and depends upon the reflective property of the wall material. So look into the solar. You might also get a question in to find solar temperature. Look into the solar temperature formula. Then we looked into climate classification, climate analysis, psychometric chart, and climate classification. These are like 4 different climate classification. Copenhagen, which is basically was used to define the vegetational landscape of the world, and which is followed majorly throughout the world. And conventionally, we use national building codes, which consist of 5 climatic zones. Uh, the climatic zones are hot and humid, hot and dry, cold, temperate, and composite. And based on a particular climatic zone, you have climate specific design, climate responsive design concepts that you can utilize to increase the thermal comfort of particular space. For example, warm and humid climate, we use ventilation, large perimeter to area ratio. We use sloped shading, reflective surfaces, and light walls. In hot and dry climate, we always try to shield the building from solar radiation, have a very low perimeter to area ratio. We also try to protect ourselves from wind, where we like use narrow corridors between buildings. And in cold climates, we always try to harness solar radiation. In hot and dry and humid, we use reflective surfaces. In cold, we try to absorb the solar radiation. And also, we have similarly to hot and dry climate, we have low perimeter area ratio, and we try to protect the building from cold drafts. So we have to look into the concepts of like infiltration. We always try to minimize the infiltration within the building as less as possible. And when we look at the composite climate, we have to provide a diverse solution because composite climate is exposed to multiple climates at different points of the year. Thermal comfort, we looked into the heat band equation, the concept of thermal sensation, and various factors that are associated with thermal comfort. We have environmental, personal, and also other contributing factors. Generally, in Fanger's EMV model, we use only the model uses only 6 parameters. That it includes all these environmental parameters and 2 personal factors, which are metabolic rate and clothing. And further moving upon, when we talk about environmental parameters, there are various, each parameter is measured specifically, like for example, temperature is measured using dry bulb, using thermometer. Velocity we can measure it using anemometers. Relative humidity, using dry bulb temperature and wet bulb temperature, you can calculate the relative humidity. Mean radiant temperature, you use this globe thermometer, and also we measure wind velocity and temperature to calculate the mean radiant temperature using Lenning's formula. When we talk about these personal parameters, one is metabolic rate. Metabolic rate is the activity level. Due to the activity level of a person, what is the amount of heat that is being generated per meter square? 1 meter is 58 watt per meter square, and the flow value is basically the thermal resistance property of the clothing that we are wearing, and 1 kilo is 0.15 meter square Kelvin per watt. And thermal adaptation concepts, we all before we talked about thermal comfort, but humans try to adapt themselves to go back to, like, reduce the discomfort and go back to thermal comfort. And the concept of thermal comfort has involves multiple parameters which are mentioned here, and thermal acceptability limits, and like there are like various standards that give thermal comfort limits which can be utilized as benchmarks and indicators when we design buildings, but these need not be stringent. And further, when we look into measuring thermal adaptation, we usually measure in terms of thermal sensation, thermal comfort vote, or thermal preferences. These are like scales, like as a 7-point scale, Bedford scale. Hi, Prasanna. Any doubt you have? Actually, I missed recording the video. I just wanted to like go back and record it. You
Okay, for me, battery got switched off. That's why I
okay? Okay,
exited.
okay.
I just
Any
wanted
any
to
any?
say thank you. No, no,
Okay.
no, sir. No, sir. Okay, thank you.
Okay. Thanks for joining. Yeah. Uh, Also, when we talk about IoT comfort models, India's in India, this thermal sensation index, sorry, tropical summer index, developed by IIT Roorkee, is calculated using this formula: 0.3 into TW plus 0.745 into TG minus 2 into square root of velocity plus 0.0841. And there are various assessment charts that has been developed to define desirable thermal comfort zone, and also to attain that zone, what and all various uh, strategies that can be utilized has also been integrated in this bioclimatic chart, where you have very high humidity at ranges between 70 to 100, and this chart also shows certain indicators where a person, what will be the uh, tolerable limit and what will be the annoying limits also. Further, beyond this bioclimatic charge, Givoni developed his own bioclimatic chart where when there is a point beyond thermal comfort zone, what kind of solution that can be used to go back to the thermal comfort zone. Example, if you have very humid condition at moderate temperature, you can utilize natural ventilation. At very hot conditions in drier environments, the concept of thermal mass with night ventilation can be used. But if you have hot temperatures associated along with very humid conditions, you, you have to use air conditioning along with dehumidification. And further moving upon, we talk about thermal properties of opaque materials, elements, and wall assemblies. Here, in this, the thermal transmittance of this is the cross section of a wall where the thermal transmittance depends upon the outdoor air thermal resistance and the indoor air thermal resistance at that surface level, like near to the wall surfaces on both sides, they will have associated thermal resistance of core convection, which has to be taken into account along with the wall's thermal resistance property. If you have homogeneous wall composition, you will have one single thermal resistance for the wall. But if you have multiple layers, each layer's thermal resistance has to be calculated, and finally you calculate the U value by taking reciprocal of summation of all thermal resistance, and heat transfer it also happens in the level of convection and radiation also. And other parameters that deal with heat transfer is the absorptivity and emissivity. Absorptivity deals with short wave radiation, and emissivity is the long wave radiation from thermal material. And absorptivity deals with the solar radiations absorptivity, like solar radiation falls on the surface, and absorptivity deals with the amount of radiation that will be absorbed. Emissivity in another case is the emission of the long wave radiation from the material. And the main concept of this slide is the major uh, thing that thermal performance of an envelope, it depends on like multiple insulations like resistive, reflective, and capacitive insulations, and also the thermal efficiency of a envelope has to be taken into account at multiple levels like element level, component level, and also assembly level. Air tightness of a building also plays a major role where we have to stop infiltration. And these performance indices, these are variable performance indices of thermal envelopes, uh, U value, thermal damping, decrement factor, thermal performance index, corrected thermal performance index, thermal time constant, diurnal heat capacity. All these you can look into for problem solving. Further, we looked into glazing. Glazing we use majorly the best parameter that can be used to measure the glazing systems thermal performances, solar heat gain coefficient, which is basically a fraction of total transmitted total solar gain via the glazing system divided by the incident solar radiation. And when we talk about the glazing system, we also have to design shading devices accordingly so that we can reduce solar radiation as much as possible in hotter climates and allow solar radiation in cold climates. Sound is basically sound basically depends on the density and temperature of a medium, and sound pressure level is usually measured in decibels, though the SI unit is Pascal. There are various parameters that are associated with sound power, sound intensity, sound pressure level, and sound exposure. And the interrelation between all these parameters are discussed when we look into these. And sound intensity level from a distance. Example, in this case, we take an omnidirectional sound source. If the observer is at 2 meters, the sound intensity level is calculated using the formula I is equal to W by 4 pi r square. When you have two similar sounds, it will result in addition of 3 decibels. This calculation you can look into it. You can either calculate it, but in general, you have two similar sound sources, you add the value by 3 decibels. And also, if you have multiple sound sources, if the difference between two sound sources are very less, you always take the highest sound source. But if you have two similar sound sources at having sound levels, equal sound levels, you just add 2 3 decibels to it, and the resultant sound level will be equal to the, in this case, it is the resultant of the vacuum 1 and also vacuum 2, which is 82 decibels, though we have like 5 different sources ranging from 62 decibel to 79 decibel. Further, I am going to just like skim up on. Majorly sound also depends, you have sound sources will have specific frequency spectrum associated with it, and each frequency will have its, like there will be the sound pressure level will be different for each frequency also, and the source of the noise or sound should be taken into account first when we start designing for build spaces, because when we have uh, like different frequency spectrum of sound, the material property to design the building also should be varied accordingly, because the material property also changes according to the frequency range. Uh, noise criteria is the maximum allowable noise in a given space, taking into account the spectrum of sound frequency also. What else? Reverberance time. This is uh, time required for reflections of direct sound to decay by 60 decibels, and it depends. Hi, Aldous, you have any doubt? Actually, the session got over. Actually, we had the session from 2 to 3. If you have any specific doubt, you can ask. As we spoke previously, materials have absorption coefficient associated with specific sound frequency, and this chart shows the noise reduction coefficient and also overall noise reduction coefficient and also sound absorption coefficient for different frequency ranges. You can see, for example, if you have a concrete block, it has a noise reduction coefficient of 0.05, and highly upholstered or occupied space with like we have like seats. Actually, furniture also play a role in sound absorption. Here it has been indicated. Uh, Sound propagation. This we touched upon earlier. Another concept was speech intelligibility, and we use speech transmission index or rapid speech transmission index majorly, uh, where the value of 0 indicates completely unintelligible, which indicates fully confident it is fully confidential. And if we have STI index of 1, it means that perfectly intelligible, where but the space will have no privacy at all. Further moving on, uh, when you look into sound effects, in major defects are echo, fluttering, echo, focusing, and creeping. Echo is something that the sound path and the sound surfaces arrives late, and it kind of uh, interferes with the direct sound. Like, and in fluttering echoes, like you'll have like in we have long paths between smooth parallel surfaces. Sound returns a small echo each time a reflection passes. Focusing sound, if we have this concave design, is basically kind of a nightmare in acoustics. Where you have at a particular point, you have all the reflected sounds coming and creating an echo. And sound creep is the multiple reflections at simultaneously arriving at a listener location. And we also have multiple remedies that can be done in terms of design to uh, neglect these defects. These are various configurations of building materials and the associated NRC values. Here you have like carpeted concrete floor which has a reduction coefficient of 0.2. When you increase the carpet thickness, it increases the noise reduction coefficient increases to 0.55. Further, the final stage of the subject, it covers lighting. Lighting, visible light is, is within the spectrum of 380 to 780 nanometers, and light sources and when you talk about light source like luminous flux is the amount of light that is emitted by a light source. It is measured in lumens, and luminous intensity is the distribution of a light source with like uh, the specific light flux emitted by a light source in a particular direction per solid angle is called luminous intensity, and illuminance is the amount of luminous flux from a light source falling on a given surface, which is measured in lux, and lux is basically lumens per meter square, and illuminance is the ratio of the luminous intensity of a surface to the projected area of the surface. It is measured in candelas per meter square. Glare, there are two glass concepts. One is discomfort and disability glare, and the concept of diffusion can be used to like reduce sharp shadows. Further, we look into color rendering index. Color rendering index of 100 indicates that it is having all the spectrum of visible spectrum emitted by daylighting, and these rendering indexes are used in artificial lighting, whether particular lighting device has full color rendering, like how much color rendering index it covers. And other concept is colored color temperature. It indicates whether the point light source is warm or cool. Further, when you look into the concept of daylighting, daylight factor is the ratio of the illumination inside the space compared to the outdoor illumination. We also look into the concept of daylight autonomy, which is the percentage of annual daytime hours that a given point in space is our specific illumination level. Here in this, you have a certain value x, and example for office space we consider 300 less. So daylight autonomy is basically the percentage of annual daytime hours that given point in a space is above 300 lux level, and the useful daylight illuminance is basically instead of having one single threshold, we have a band ranging from, in this case example, we have band ranging from 100 lux to 2000 lux. Thank you. Uh, so thanks for listening. This video was for exam revisions. All the best for your exams.